Dear students, today we are going to discuss about transistor series voltage regulator, and in this case we will be doing the experiments for line regulation and load regulation, and the aim of the experiment is design a series voltage regulator to obtain an output DC voltage of 5 volt from 8 to 12 volt DC input, and maximum load current is 50 milliampere. Obtain line and load regulation graphs. Okay. So, we will be doing this by using the zenor voltage zenor diode. Okay. So, let us see the circuit diagram. This is the circuit diagram, and here is a voltage source, that is 8 to 12 volt, and we have to regulate this input voltage for an output voltage of 5 volt. So, if there is any change in the input voltage, and it should be regulated at the output, and we will have a 5 volt at the output. Okay. So, for this we require a transistor SL100, and it is a power transistor, and there is a zenor diode, that is S at 5.6. Since we need an output voltage, regulated output voltage is 5 volt, we need a zenor diode of 5.6 volt. Zenor of 5.6. You know that zenor diode will be working as an ordinary diode in the forward biased condition. In the reverse biased condition, it will be working as a constant voltage source. See, whenever the input voltage, negative voltage exceeds its breakdown voltage, it will act as a constant voltage. It will give a constant voltage, because whenever the whatever be the input voltage, the output current will be increasing, and the same voltage will be appearing across it. Okay. So, that is the working of the zenor diode, and let us do first the line regulation. Actually, the line regulation is the curve between input voltage and output voltage. So, we have to vary the input voltage between 8 to 12 volt, and we have to observe the output voltage, and we need 5 volt at the output. So, that is the regulated output. Okay. Let us see. For that we will first give the maximum voltage is 10 volt input at this side, and we will check whether the output voltage is 5 volt, and then we can vary the voltage and we can observe the output. Okay. So, this is the expected graph for this line regulation. Okay. For an ideal case, it should be straight line. Okay. So, this is the input voltage versus output voltage curve, and this is the line regulation curve. Okay. So, let us wire up the circuit on the breadboard. So, let us do the wiring of the series voltage regulator. Here we need a SL100 transistor. This is the SL100 transistor, and this is the emitter, then base terminal, and this is the collector terminal, and we need 330 ohm resistance at the input side. So, this is the 330 ohm, and its connection is from collector. Collector one point is at the base of this transistor, and other point is at the collector. Collector you can see here, and next is from the emitter. There is an ammeter in the circuit. So, this is ammeter. See, you can see this is the ammeter, and it is positive terminal, it is negative terminal. Positive is connected to the emitter, and negative is connected to another point, and from that negative there is a resistance of 100 ohm, and each of these resistance are power transistors, have a 1 watt capacity. And next is the zenor diode. Zenor diode is connected at the base of the SL100. You can see this is zenor diode, and negative of the zenor diode has a black mark. You can see here black ring, and negative is connected to this point, and positive is connected to the ground point. And a voltage source, we need a voltage source from 8 to 12 volt, and so voltage source positive is connected to this resistance terminal, that is that means it is connected to the collector terminal of this transistor, and a negative is connected to the ground. Okay. So, this is the connection, and output is taken across the resistor, and so output means that we need output there is a voltage voltmeter, we require a voltmeter, so we are using a digital voltmeter. You can see this is the digital voltmeter, and positive is connected to one of the terminal of this resistance and negative is connected to the ground point. Okay, so this is a circuit setup, and next we are setting the input voltage to, first we will set the input voltage to 10 volt. So what will be the output voltage, and that will be displayed on this voltmeter. You can see here that this is 5.17, that is near to 5 volt. That means whenever the input voltage is 10 volt, it is regulated to output regulated to a voltage of 5 volt. So whenever we are changing this input voltage, see, whenever we are changing this input voltage, whenever we are lowering it, the output voltage is 5 volt itself. So whenever there is fluctuations in the input voltage, the output voltage is regulated to 5 volt. So when the input voltage is 8 volt, then now the output voltage is 4.94, and whenever we are increasing the input voltage, now it is 9 volt, then the output voltage is 5, there is a slight increase. Whenever the input voltage is 8.8 10, the output voltage is 5.06. When the input voltage is 10.9, output of 5.10. That means there is a slight increase in the output voltage. Even though it is regulated, there is a slight increase. So we need a slightly increasing curve between the input voltage and output voltage. Okay, so that is a line regulation curve. In order to draw the graph, you have to take the readings of input and output voltage. Okay. So now from this experiment you can see that the output voltage is regulated to a voltage of 5 volt. Okay. Now we are going to do the series voltage regulator. In the series voltage regulator, now we are going to do load regulation. So here what we need is, we need a rheostat here, and here we are using a 1 kilo ohm rheostat, and here one thing you should remember, that never let the resistance to become 0 kilo ohm. Okay, whenever it becomes to minimum value or 0 ohm, then the current will be increasing sharply, so it will damage the circuit. So bear in mind that it should be above 0 ohm. Okay, so let us start doing the experiment by placing this variable point of this rheostat at the midpoint. Then we can find whether in which side it is increasing or decreasing. So let us start the experiment by keeping the rheostat point to its maximum value. Okay, so this is the circuit diagram, and input voltage we will keep at 10 volt. Here we need a constant input voltage, and the other circuit components are similar, that is SL100 is the transistor, and zenor diode is SZ 5.6, and there is a resistance 4.7 kilo ohm and a voltmeter which shows the output voltage, and we will get the regulated output voltage of 5 volt here. So we need a 0 to 10 volt voltmeter here. So we are using a digital voltmeter, and there is an ammeter. It is also a digital ammeter. Okay, let us next wire up the circuit. Okay. Now let us wire up the circuit for the line regulation, and SL100 is connected here, and a resistor which is time value 330 ohm, and which is connected between collector and base of this transistor, and this is the emitter, base and collector. Okay, so the zenor diode in negative side is this one. This is connected to the base of this SL100, and other point is grounded, and this is the resistance and which is connected between the emitter and between the ground, and also there is an ammeter connected in between at the emitter side of this transistor, and you can see this is the ammeter. Okay, this is a digital meter, this is a digital ammeter, and it is connected to this point, and there is a voltmeter. You can see this is the voltmeter, and which is connected in between the input side, that is between this resistance side. Positive is connected here, negative is connected to this ground. Okay. So there is a rheostat. You can see the rheostat connection. This is the point where we are connecting the rheostat, and based on the circuit we can connect the rheostat at this point. One terminal is grounded and is other is connected at this point, that is between the ammeter terminal. One of the ammeter terminal, there is a negative of the ammeter is connected to this rheostat point, and other rheostat point is connected to the ground side. Okay. So for doing the experiment, before switching on the power supply, we have to keep the rheostat variable point at the maximum resistance position. This is the maximum resistance position. Okay. So now we are switching on the power supply, and the input voltage is 10 volt. Here it is adjusted, and now let us vary this rheostat terminal. Okay, let us see. I am varying this rheostat terminal. You can see here. Then you can notice a change in the current. You can see here that whenever you are reducing the value of the resistance, the current is increasing. Now it is 6.3, 6.2, and here you can see that this is the voltage. Whenever we are varying the rheostat, there is no further change for the output voltage, that is somewhat near to 5 volt. Okay. So this is the way we are doing the experiment. You can continuously change this rheostat. You can see here that now the current is increasing 9.9 like that. Whenever its position is changing, the current is increasing like this. Okay. So now it is 15 milliampere, 16. Now it is increasing. That is, now the resistance is decreasing, so the current is increasing like this. So load regulation is the curve between the input voltage and output current. Okay. So whenever there is no load, that means whenever the resistance is rheostat variable rheostat resistance is decreasing, the current will be maximum. So at the no load point, the current will be maximum, but at the full load point, current will be minimum. Okay. So we started from the full load, and then we are reducing the load. Okay. This is the load actually. Okay. So this is the way we are doing the experiment, but correspondingly input voltage is, whenever we are setting input voltage is 10 volt, but the output voltage is regulated to 5 volt. Okay. So in this experiment, whenever we are changing the load, the current will be increasing. Okay. So whenever plotting a curve between input current, when we are plotting a curve between, in the case of line regulation, we are plotting the curve between current, output current and output voltage. Okay. So this is the way we are doing the experiment, but you can see here that there is a slight change in the output voltage. Okay. This is the way, and we are doing the experiment, and we have to note 1 or 2 readings of the current. Input voltage is constant, and current and output voltage. Okay. So that's all about this experiment.